Your next 7 Caillou series challenge is called Sort by Last Char, or character. Given a string of words, X, you need to return an array of the words sorted alphabetically by the final character in each. If 2 words have the same last letter, the returned array should show them in the order they appeared in the given string. All inputs will be valid. So, basically, nothing new here, right? You get a collection. Well, they're not even giving you a collection, right? They're giving you a string that's going to contain a bunch of words. So step 1 will be you'll have to sort of parse the words from the input string. You need to convert it into a collection of individual words and then sort them, but by the last letter in each word. So that's clear. It's, what's not clear is maybe how to get started, but that's why we do this, right? That's why we practice. So pause the video, try it out, and come on back when you're ready. So we'll get into it. The first step, of course, would be to take this string. I hate X, so I'm going to I'll use something like this, or let's just call it text. It's a text, maybe it's a paragraph of words or whatever. And so they promised all inputs will be valid. I'll assume they're individual words. It's a little more complicated. You could scan through this, right, and make sure everything is a letter character. If you really wanted to overkill it, you'd need some kind of dictionary to check the words against, make sure they're valid words, but that's complete overkill here, so we won't do that. So let's start with that, though. We need string words. We'll make this a string array, right? We want a collection of strings that we can sort. And we've seen in the past that strings have a split method. And if you'd like to read about that, go to your docs page, string split, and refresh yourself if necessary. But it does what you'll think it does. By default, it should use a space as the delimiter, but remember, you can put something in here. If you had a CSV file, you could make it split on commas instead of spaces. But if you leave it blank, it should just split. So imagine you had a paragraph of text. When you call split on it, it's going to grab each word separated by a space character and make this whole collection. Now this array, in particular, it's an array of words. So that's good. That's half the battle, right? The next part is that we got to sort these, and we have to sort them in a weird way. So in a recent challenge, we found out that this array class has a sort method, right? And you could simply pass an array to it. And this is great, but not so great here, right? Because sort has a good default implementation, and it will sort the words in alphabetical order from their lettering from the left, right? How you would see the words in a dictionary. So let's return words, and maybe this will give us an idea of where this is going wrong. Yeah, you can see this first test here, right? They're differing in their first value. Index 0 would be the first one, right? We gave ABC, they're expecting CBA, right? Because the last letter, look at this collection right here. The last letter here is an A. That comes before B and before the C here. So CBA should be first, but we're returning ABC first because this method by default returns in alphabetical order, which is ABC. So darn, right? That would have been so handy if we could just use array sort and it did what we wanted it to do. If only there were a way where we could change how sort sorts. And hopefully you're thinking like that, and it sets off some alarm bells or your spidey sense, and you go check out this array sort. And we know that a lot of times these methods have many overloads. And so if you read through them, you'll find something useful. In particular, sorts the elements in a one-dimensional array using the specified I-comparer. And that kind of sounds like, it's how it would compare elements in the array, right? So I think this could do what we wanted to do using the specified I-comparer. See if they have an example here for us. And they do. So it uses a reverse comparer. So check out what they did. They extend this I-comparer class to make a reverse one. And it does these in backwards order, I guess, by swapping the Y and the X. And if you just take it by name alone, just sort in reverse order. So you have a collection of words here. You make your reverse comparer. Then you call sort on the words, right? But notice this sort uses your reverse comparer. So if you look at the output below, using the reverse case insensitive comparer, you notice that was different than the default comparer. Over jumps, brown, quick fox. So yeah, you get the idea that you can you're not stuck with the default implementation for strings or anything. You can write custom comparers that will compare things the way you want them to. And so, okay, what is this I-comparer thing? It's an interface. It defines a method that a type implements to compare two objects. And so you can imagine as the sort algorithm works, it's comparing two elements at a time, and it might swap them or it might not swap them. As it's doing its sort, it'll go through every kind of pair that it needs to of elements to get them in place. You can think of how you might arrange your cards. If you're playing cards and you're holding them, you might arrange them in ascending order or by suit, depending on which game you're playing. Something like that. So we did get an example of this with reverse compare, but you can look at another one here. This has a generic type, right? We'll be using strings, so you can imagine instead of box, we would have a string type. And so feel free to go through these examples and read as you like. Note, we recommend that you derive from comparer T class instead of implementing I-comparer T interface, because the comparer T class provides an explicit interface implementation of the compare method and the default property that gets the default comparer for the object. So that may not be too meaningful to you at this point, but we can follow their advice and use comparer. And if we look at comparer, we can see it is derived from I-comparer, right? This is the syntax that denotes that, this colon, when you make your class name, colon, and then you can list classes that you derive from. I know we haven't talked much about polymorphism, and I don't want to go down that rabbit hole here. I'm happy to make a separate video on that. That's not the focus of this video, so we won't get too much into it, but let's say it's enough to say that when you derive from another class, you sort of get everything from the base class, and then you derive it to kind of sprinkle on a few extra characteristics that are more relevant. So, a classic example, let's say you're making animals, and your animals have behaviors. They might have a method that makes them eat, because all animals need to eat, right? And then you have, you want something more meaningful, because now you need a dog animal. It's a more specific kind of an animal, but it's still an animal, right? So it still needs to eat. But it might have some extra behaviors, like it might have a bark behavior. And so that wouldn't make sense for all animals, but it makes sense for a dog. And so similarly here, comparer can add some traits that the I-comparer doesn't. And when you see a class name start with an I like that, it's telling you that it's an interface. So feel free to go through this documentation as you like. They got that box example here where they're going to sort by height, length, and width. And that might be beneficial to you. You see now they're deriving from comparer of type box. We'll copy this and use comparer with type string. You can see here they do the same thing with iComparer for demonstration purposes. Again, they recommend to derive from comparer T, so we'll just follow their advice and use comparer. I think that's enough to get us started. So back to our method, we see from array sort. Now we're not going to use the regular kind. We're going to add this comparer in, but we got to make it first before we can call it in the sort method, right? So let's do that. We'll make our own class and we'll call it public class. Let's call it last char comparer, right? Because we're comparing the last character in words. You can name it whatever you want here. I'm just trying to think of something meaningful. Remember, you hit that colon and that allows us to build. We're not building our class from scratch anymore, right? We're going to build it off of whatever we list next. And in the examples, they told us use comparer, and our type is string. We're not working with boxes, we're working with strings. So that's why I did that. Okay, we'll add curly braces to define the scope of our class. And really the only thing special we need to do in our class is to override that compare method that they told us about. Let me make sure you caught that. Compare, go down to methods. This is the magic, right? When overridden in a derived class, that's what we're talking about. Our last char comparer, whatever I called that, is a derived class, performs a comparison of two objects of the same type, string in our case, and returns a value indicating whether one object is less than, equal to, or greater than the other. And you can imagine if you have that information, you can sort two objects. You're holding two in your hand, and you can ask some service, our compare method here, give me a value denoting whether the first one's less than, equal to, or greater than the second one. And you can click on that and look, there's nothing preventing you. You can go down the rabbit hole of documentation all you like. And that's kind of the same message we just said. Here you go, returns an integer. This is how they do it. This is how they denote the ordering of two elements you're examining at any given time. If the return value is less than 0, it means that the first value was less than the second one. If you return 0, it means that they're equal. And if you return a positive value, it's saying that the first value is greater than the second one. I like to use -1, 0, and 1, but according to this, you can use whatever integer values you like. So that's good. Let's go back and let's override that compare method. So we could say we've got to make it public so it's accessible to people using our last char comparer class. And then if you haven't seen this, this is the override keyword. This is saying we're not making a new method here. We are overriding a method from this base class or one of its base classes. You can imagine you could have chains of these where last char comparer derives from comparer, and then we saw that comparer derives from iComparer, and so sometimes you can get chains of these. But that's all the override means. It's just an extra word saying, hey, this isn't a new method. And I think if you omit the override keyword, a lot of times they'll warn you and say like, hey, warning, the method you're making sort of masks this other method from a base class that's already present. But we want to override. We saw that it returned an integer, right? And it was called compare. And because our generic type is strings, we will say string. I'll call mine S1 and S2. Okay, let's define the scope of our method. And so what do we want to do for our compare? Well, we need to compare the last characters. So I'm going to start just by storing the last characters. I'll call it ch1 for character 1, right? And we'll say that's from s1, and we know how to get the last character, right? We could say s1.length minus 1, right? Because our indexes are 0-based. That's why we have to have the minus 1 there. Otherwise, we'll overrun the size of the string. And similarly, you could get the last character in the second string by doing the same thing on S2. Good. We've got the 2 last characters, and that's all we care about per the rules of our challenge, right? That's what they told us to compare against. And what I'm thinking is that when the characters are equal and we return that 0, it's going to preserve the original ordering. Because remember, in the instructions, they told us if things come out the same, keep the same order. And I think that should work. I think that we'll get that by implementing it this way. The order will be preserved. But we'll certainly find out if not. So now that you have the 2 characters, we know if ch1 is equal to ch2, what'd they tell us? Return 0. Means they're equal. You don't have to change the order. They're the same thing. And then finally, you've got 2 other cases, right? It's either char1 is less than char2 or it's greater than char2. So I will kind of wrap that up in using the ternary operator here. If char1 is less than char2, we've seen this a few times, so hopefully you're comfortable with this syntax now. And that's saying, you could do this in an if-else if you wanted, that's fine too. If character 1 is less than character 2, remember it said return a negative number, we're doing that. And then the second value corresponds to the otherwise case, where ch1 is not less than ch2. And then we're just going to return a positive number. If you want to do 77 there, go for it. So that's how we compare strings by their last character. So now, instead of the default, right, we saw in that overload, we give it the array and we have to give it our comparer. So I'm going to instantiate our comparer. And we'll put it right in the method there. So we can say, we'll do it right in place. New last char comparer. Spelling matters. Okay. And then, provided I didn't do anything wrong. System, okay. And we'll give this a go and see if that does what we want it to do. Compare could not be found, so let's go look at that. Make sure we got the namespace we need. And look at, you can see, for comparer, we need system collections generic. So let's go ahead and add that. That's fair. Using system collections generic. Let's try again. Come on, Bessie. There we go. There's a green we like, but you gotta pass the attempt too. And there you have it. Pretty cool, right? So that's kind of eye-opening. I know that was a little bit of a jump for a relatively beginner series. You got this polymorphism kind of stuff and interfaces going on. Don't beat yourself up if you don't totally follow along yet. The stuff we're going to repeat, and that's what's helped me in this industry, is that just accepting that it's okay to not understand all the time. Let a little bit seep in at a time, come back, repeat, and you retain a little bit more each time. Definitely continue to read through the documentation for the parts that are confusing, and you always have me as a resource. I'll answer your questions. But yeah, hopefully, if you're a nerd like me, this was really cool. It was like, whoa, I have sort, and I'm not just stuck with the default behavior. I can sort by any way I can possibly imagine. Anything that I can write in computer code, that's pretty powerful. And you could And then you're not stuck. You could maybe sort it this way this time, and later on, some other conditions are true, you sort by some other mechanism. You know, really, really cool and powerful stuff there. So yeah, I'll go ahead and submit like this. I don't think, no comments or anything in there. And then you know what to do. Go through the solutions, see what you can learn from me, see what you can learn from other people. And there you go. You knew the linkers were coming, right? Nice. Yeah, good stuff. So see what else you can put in your tool belt there. Otherwise, you know what to do. Hit me up with questions, comments. I'd love to see your solution. Otherwise, I'll see you in another video. Thank you for watching.